CannonEcon.
Hey guys, Mr. Cannon. I am here with a hopefully quick-ish video just on refreshing subsidies, and then after that we're going to get into the actual calculations of subsidies. That part will be a little longer, but it is fairly review heavy with calculating taxes, so it shouldn't be too bad. So here we go. Brief reminder that subsidies are effectively the opposite of tax. So if a tax is the government saying for every unit that is sold of an item, you have to pay the government, a subsidy would be the alternative. So the government is looking to pay the producer a specific amount of money or incentive for every item sold. So the classic example is like for agriculture, let's say for every bushel of whatever, I don't know what avocados are sold at, but for every avocado produced, the government's going to provide 25 cents onto the price of that avocado. That's going to incentivize production for those goods. It's going to do a couple things. So down here you can see there's a couple main goals, not to go through all of them, but it's going to increase the supply of that good because it's an incentive for producers to make more of something. It's going to increase revenue for those firms. And as a result of the increase of supply for those goods, it's going to decrease the price for consumers. So at the end, the government spending leads to producers making more money and consumers spending less money. A couple drawbacks that, and I'm not going to go through all these either, but a couple drawbacks would be the fact that it's government spending money and kind of interfering with the free market. So although some subsidies do help failing industries or industries that are needed to be counted as necessities. So a lot of these go back to, for agriculture, the Great Depression, where farmers are kind of shutting down left and right. And so you might provide subsidies to make sure that, one, there's enough food in the country, two, that the food is cheap in the country, three, that farmers are making enough money to survive themselves. Some of the problems down here you can see, I'll just give you one example with Boeing here. So a good example is the government in 2013 paid about $13 billion to Boeing in subsidies and tax incentives. The argument would be that it's great to have a strong aeronautical company in the U.S. The argument against would be that same exact year, according to Boeing's own annual report, they had a record $440 billion in backlogged sales that they were waiting to produce, and another record $135 billion in sales made just that year. So the taxpayers are paying $13 billion that year to help a company out that is clearly fine on its own. So that would be one of the negatives. And obviously that leads to taxpayer spending. The average American household loses about $800 a year because we are paying for subsidies. And clearly some of the companies that are getting those subsidies do not need them. Down here you can see the same thing for farmers. Most of the subsidies go to a very select few companies and farmers. So obviously, there might be some farmers necessary that might need those kinds of subsidies, but most of the subsidies go to the top 18 or so producers of agriculture, and it really actually hurts the free market because what you wind up seeing is most of the money goes to these few farmers or these few relatively few farmers, and then it tilts away from an actual competition-heavy market, and so that leads to some of the deadweight loss and inefficiency that we see. So reminder on graphing subsidies. Let's go get our pen out here. Reminder on graphing subsidies. So if we are looking at a typical demand and supply graph, I'm going to make this wider. Demand and supply graph, and we've got our equilibrium price here. That's our quantity to equilibrium and our price at equilibrium. So the government's going to pay a producer a fixed amount of money for every unit produced. So that's going to incentivize production. So if I'm farming avocados and the government says we're going to pay you for each ear of corn you make, I'm going to be at least partially incentivized to increase my production of whatever good corn is being subsidized. So that would increase my supply to the right. That has a couple effects here. First, because there's an increase in supply, we're going to see a new equilibrium price that will be lower. So consumers will see this new lower price and they'll say, hey, thanks, Congressman, whoever, appreciate it. So food will be cheaper. That'll also lead to an increased quantity at the store. I'm going to call this QSB, or quantity after subsidy. I know there's no space down there. Because the increased subsidy has allowed, so we'll see more corn on the shelves and it'll be cheaper. Now, when we're trying to graph the actual subsidy itself, what we do is we always go for taxes and subsidies. We go new supply, which is here. and we take that to the old the old supply line. So new supply equilibrium to the old supply line. So if there's nothing below, so we have to go up. And this represents the volume or the size of that subsidy. So the height of this right here represents how large is the subsidy. So if it's bigger, it'll be a large subsidy, smaller, it'll be smaller. Now what I do is I cut that across, down and back, and this box gives me my government spending, or government expenditure as well. So before with taxes, we would call that government revenue. Here for subsidies, we would call it government spending. Now we've got on the right here, we've got our deadweight loss because government involvement always going to lead to some inefficiencies. And we have a new price now. So we see down here, the consumers receive a lower price, so they're happy. But after the consumers pay this to producers, the government goes ahead and gives them this height, this bread box height, in their subsidy. And so the producers actually feel like they get P sub P. So producers are happy because they get this higher price. Consumers are happy because they get this lower price. Now, finally, we're going to see an increase in surplus for both groups. So whereas my consumer surplus used to be all the way to their equilibrium price there, right? Now they don't actually get this price. They get a lower price of PC. So their surplus goes all the way down to their new price. So they're stoked about that. Now, in terms of producers used to get their surplus all the way up to their original price of PE, but now they're getting all the way up to P sub P. So they've got this new surplus here. So you'll see that they actually interact a little bit. They overlap. That's my producer surplus, and this is my consumer surplus. So they'll actually overlap quite a bit. But that's good because both groups benefit in that case. Now, in terms of actually calculating, here are the things that we're going to try and find. So we're going to try and find, before the subsidy, we're going to start with that. We're going to try and find equilibrium price, price intercept, consumer producer surplus, all that same stuff we've been doing, but we're going to find it for this set of functions above. So let's start there. So I've got a graph here. We're going to take these functions and we're going to try and find first our equilibrium price, our starting consumer and producer surplus. So as a reminder, when we want to find equilibrium, we are literally finding where demand and supply are equal. So we have to set these functions equal to each other. So if I get a smaller size here, we're going to go 60 minus 2p equals negative 20 plus 2p. So I start breaking this down. Plus 2p here gets rid of that. Plus 2p there. Plus 20 gets rid of that. Plus 20 gets me 80. Oops, 80 equals 4p, excuse me. 80 equals 4p. And that's going to give me an equilibrium price of 20. So what I recommend is keeping track of all of this. So my equilibrium price is 20. I know that now. And I would actually graph this out so that you can see every step of the way. Once you start looking for surplus and all that, you can see the actual numbers because you're going to have to start basically now memorizing these formulas. And the easiest way to do that, I think, is looking at the graph and saying, what is the graph telling me? Because if you can read the graph, then you're good to go. The graph, pH. Okay, now how we find equilibrium quantity is how we have with taxes in the past. All we have to do is take that new price at equilibrium, plug it back into either of the functions. Plugging it back into either of them, especially if you have these nice flat numbers, should give you identical numbers, so it doesn't matter. So I'm going to plug 20, and I'm going to plug 20 back into my demand curve. So QD equals 60 minus 2, and I'm going to use my equilibrium price of 20. That gets me 60 minus 40. That gets me an equilibrium price, quantity of 20. So my equilibrium price is 20. I'm going to note that down here. Okay, so we're now all nice and happy. Now, to find total revenue, it is just price times quantity. And because we have a nice easy graph, all we have to do is look at it. So if I'm looking at where's my total revenue, well, we're spending this much money, we're spending this much money on this many goods. So it's just a simple base times height. That gets me the area of this. And so we've got 2 times 2, 4. 400 is my total revenue array. Okay, so that should be reviewed. Same thing with consumer and producer surplus. Before we even start that, we need to find our demand and supply intercepts. So as a reminder, this graph will help. I'm trying to find for consumer surplus, I'm trying to find the area of this triangle right here. Now, I know my base is 20, right? I know my